Okay, so this video is going to do Chapter 12, the problems, the math problems, questions 16, 17, 18 on page 410. Alright, so question 16 asks if a commercial solar cell with a maximum output of 2 amps times 0.5 volts costs $30, what will be the cost of a photovoltaic plant per peak kilowatt? So they're talking about a plant cell, each cell that would be inside a module. So each one of these little photovoltaic cells, we're going to fit into one another. And we're going to work the problem for this where they're giving you the amperes of each cell and the voltage of each cell, and you got to find the watts. So that's step one, is watts. So 2 amps times 0.5 volts equals 1 watt apiece. And each one of these watts in this solar array costs $30. So 1 watt is equal to $30. And we want to know how much would it cost to have 1,000. So that's pretty easy. From here I just have to do my peak kilowatt. So I want to do 1,000 watts to make 1 kilowatt. So it's going to be this times 1,000. Going to equal 30,000. So that is my answer for question 16. Pretty straightforward. Let's start working on 17. Alright, so question 17. We have discussed a solar cell farm for the conversion of sunlight into electrical energy. If the solar cell used have an efficiency of 10%, what area of land is needed to produce 1,000 megawatts, assuming the mean insolation is 500 watts per meter squared? So in the problem they tell me that 500 watts for every square meter is able to be produced based on the sunlight, but the system I'm going to install is only 10% efficient. So it would be like a single junction cell that I'm going to install. So the equation I'm going to create is my Q, which would be my 500 watts over a meter squared, right, times my efficiency of 10, so 0.1, equals 50 watts per meter squared. So the solar cell system can only produce a maximum of 50 watts every meter squared. But the problem wants me to figure out how much space I need to install something that's going to produce 1,000 megawatts. So that's 1,000,000 watts in the system. So I'm going to do a little erasing and we'll work the rest of the problem, keeping in mind that the solar cell is producing 50 watts every meter squared. Alright, so I have to change my watts to a megawatts in the system. And so I'm going to take my 50 watts and divide it into 1,000,000 watts of energy, which is going to equal a megawatt's worth, which comes out to be 20,000. And that is the unit of megawatts meters squared. But that doesn't give me how much space I need in meters still. And so the next step is to find 1,000 megawatts of power. So now that it's in megawatts, it's 20,000 megawatts of power, I need to know how much I need to produce my 1,000 megawatts within my system. So I'm going to do my 20,000 times my 1,000 megawatt system over meters squared. My megawatts goes away, and I'm going to get my answer in meters squared, and it's going to be such a big number that I'm going to just write it in scientific notation. So I think I'm going to just put in the 2 times 10 to the 7 meters cubed. You can write it with all the zeros if you want. I'm just trying to make it a smaller number. Alright, so let's take a look at question number 18. Alright, so question 18. A commercially available solar cell module puts 3 volts and 0.1 amps and measures a 5 centimeter by 8 centimeters. How large an array is necessary to provide an output of 40 watts? Estimate the power outputs of the panels shown in figure 12.29 on page 411. And if you had the book and you were looking at page 411 and looking at the figure, what you would see is a camel with a solar panel on its back. And so they're basically saying how much power can I get if I need to make 40 watts. And so just keeping in mind that amps times volts equals watts, this starts out to be very simple, and that is for my standard system, and the system size is 5 centimeters by 8 centimeters. So for this size system, it produces a set of 3 volts times an ampere of 0.1. So when I put this in, really easy math again, just moving my decimal over, and that's my watts, and then this, of course, 5 times 4 is 40, that's centimeters cubed, or squared, sorry, it's a cubed, losing my mind here. So here we go, so for this solar panel of this size, I can make this wattage on my system. Alright, so what I want to do is to solve the rest of the problem, we want to make 40 watts of power. So to do this, I'm going to do this little solar cell and divide my 0.3 watts into the 40 watts of power, and what I come up with is 133.4, and that's how many solar cells I need. Alright, I need 133.4 solar cells. Each one of these solar cells is 40 centimeters squared. So if I need 133.4 solar cells, so that's how many I'm going to order, I want to know how much space this is going to take up. Each one of these cells is 40 centimeters squared, and so I'm going to take 133.4, and that is a solar cell, and times that by the area of 40 centimeters squared. And when I times those into each other, I get 5,033, whoop, that's a 3, and that's centimeters squared. So this would be the area I'd need. I need 5,333 centimeters squared space to put all 133.4 solar cells to make my 40 watts of power. So that's how we do question 18. If there's any confusion at all, feel free to sit down, meet with me, and work through. I'm happy to help anybody out. I know that they're fairly straightforward. We're just playing with amps times volts equals watts. That's all you're doing, just moving back and forth.